So that's a watermelon. We talked about watermelons in the minerals. Watermelon contains, if you remember, SOD, and it also contains catalase and other enzymes in the seeds. But you'll notice that this watermelon has got white seeds, which has been by natural selection or genetic engineering maybe. The black seeds are taken out, but the black seeds are where the seed is the embryological form of the plant, and therefore contains all the DNA and the material for the new plant. Okay? So if that new plant is a rich source of something, the seed is even more concentrated that it's got the codes in it. So this is why commercially they extract SOD and catalase from the seeds of plants, and particularly in this case with those two from watermelon. So did you know that even though eating watermelon can cause a river of sticky fluid to run down your forearm and drip off your elbow, there's good for so much more. It's true. The results of recent studies suggest that watermelon juice can help reduce muscle soreness after a workout. The amino acid citrulline, which is abundant in the red beauty, plays a role in determining how much your muscles will ache when you get more physical exertion than you're used to. Now, this particular study discusses only watermelon juice, but I'd lean towards eating the entire fruit, so I wouldn't have to worry about a big sugar jolt in my system. After all, citrulline is in the juice. It must be the whole fruit as well. So citrulline, if you remember, just converts around that urea cycle to making arginine. So there was a time when watermelon and watermelon seeds were being promoted as a natural alternative to Viagra, because Viagra works by stimulating the production of nitric oxide from arginine. So let's have a brief look at some non-proteinogenic amino acids. What this means is ones that don't build proteins. So in that group, we've met taurine. So taurine is an amino acid, but it doesn't build proteins. Now, I think this is perhaps maybe not in your manuals, but it will be in the manuals online. So you might want to just make some notes here. So we've got a very common one is N-acetylcysteine. N-acetylcysteine, or NAC, is a derivative of cysteine. It may help to activate detoxification of chemicals. And we talked in the last module about anesthetics being a typical example. N-acetylcysteine is used in hospital emergency departments for overdose, particularly things like paracetamol. So NAC helps to stimulate through the cysteine part the production of glutathione, which is the main detoxifier and antioxidant. The acetyl part, which comes from acetyl-CoA, the active form of vitamin B5, helps in acetylation, which is again a phase 2 detoxifier. The cysteine goes on to make other forms of sulfur like PAPs and taurine, so it helps by sulfation itself. And the cysteine itself, because of the sulfur, can be a detoxifier. So there's 4 ways that N-acetylcysteine helps to detoxify. So it's one of the first things as an emergency if someone has a toxicity issue, and they maybe wake up in the morning with a headache. Oh, what have I eaten last night? And it's a chemical reaction to something that they've eaten. N-acetylcysteine most of the time will sort it out. If it doesn't, then you look for the other things to stimulate glutathione and other pathways. So NAC is certainly worthwhile putting in your holiday pack, as I said before. If you're away and you're traveling and you have exposure to foods and chemicals which you may not be accustomed to in your own country, NAC can be a great godsend there. Carnitine. Now, carnitine is something we hear about, in particular in relationship to what we call the carnitine shuffle. So this is a little drawing here that we see that we make carnitine primarily from lysine and methionine. So protein-bound lysine and methionine. So those are the 2 amino acids that go on to make carnitine. So we've got lysine and methionine. This then goes on to form trimethylylysine, and with the hydroxylation, which requires vitamin C and iron. We then aldosed, which requires vitamin B6, and then dehydrogenated, which requires B3 or niacin, and again hydroxylation with vitamin C and iron forms carnitine. So carnitine really is lysine and methionine, but requires vitamin C, iron, B6, B3 to activate it. So it's a compound, it's an amino acid derivative, if you like, and its function is to carry fatty acids. When we break down fatty acids through lipolysis, as it's called, we're breaking melting fatty acids. So fats that we store in the body are called triglycerides. So they're combinations of 3 fatty acids linked together, maybe 2 palmitic and 1 stearic, 2 stearic and 1 arachidic, and so on. Different combinations here of fatty acids. So what happens is we use lipase, which is a digestive enzyme, but is also secreted in the body, and here it's called hormone-dependent lipase. So hormone-dependent lipase is usually guided by the hormones of thyroxine for normal metabolic rates and adrenaline for fast rates. So if you need to mobilize fat for producing energy, you'd use adrenaline. So when you're under stress, this is why you burn fat better. Okay? For normal everyday burning of fat through the fatty acid cycle there, the normal burning of fat requires thyroxine. So if your metabolic rate is getting slower because the thyroid function's going down, usually you tend to gain weight and put more fat on. The fastest way to lose the fat is to get stressed. So a good bit of stress is the finest way. The bigger the stress, the quicker you can lose weight, because the higher your adrenaline, and then you go into breaking down fat, lipolysis. So lipolysis, once you've broken those 3, you split the 3 triglycerides into single fats, they then go to outside of the mitochondria, the membrane there, and then they're carried into the mitochondria, into the furnace in other words, across the inside wall and the outer, or inner and outer membrane there, and by this carrier called carnitine. So the carnitine takes the fatty acid inside the mitochondria, deposits it, and then recycles back, why it's called the carnitine shuffle. So if you don't have enough carnitine, it's very difficult to burn fat. And this is why with the power lifters and trainers who want to decrease their body mass and increase their body lean tend to use carnitine a lot. Now, you can acetylate this, which has advantages that it can donate the acetyl group to go on to make things like acetylcholine in the brain and things. So acetylcarnitine is a very useful compound. It's what the sperms use entirely for their energy with their tails. So the energy that a sperm uses to wiggle its way up the fallopian tube is acetylcarnitine. So couples who are having difficulty conceiving, from the male point of view, check the acetylcarnitine. Because if they haven't got enough acetylcarnitine, the boys can't swim fast enough, or boys, because they're not just boys, they're boys and girls. So acetylcarnitine is an acetyl form of carnitine. It is naturally produced by the body, but it's often taken as a dietary supplement. Acetylcarnitine is broken down in the blood by plasma esterases to carnitine, which, as I say, makes the carnitine shuffle, which is used by the body to transport fatty acids in the mitochondria. So acetylcarnitine has a use as an energy supplier, a donor of acetyl groups, which helps people go on to make acetylcholine, especially if they're having memory problems. So acetylcarnitine is an important component of a lot of memory formulas because it helps to stimulate, synthesize acetylcholine. I think Jill found when you took acetylcarnitine, you also found you weren't so hungry. So if she took it before breakfast, like all amino acids are better taken 15 minutes before breakfast, that she'd have breakfast, but she wouldn't be hungry so much before lunch, and sometimes it was 2 or 3 o'clock before you thought, oh, I must have something to eat, because she was burning fat better. So the formula is a substance which is used, to help people to decrease probably their appetite, because they help to burn their own fat better. Okay. So acetylcarnitine. Ornithine. This is one of our favourites substances. Now, this is part of the urea cycle. And again, ornithine is a non-proteogenic amino acid. In other words, it doesn't go on to make amino acids that play a role in the urea cycle. Ornithine is abnormally accumulated in the body in ornithine transcarbamase deficiency. Ornithine transcarbamase deficiency is the most common urea cycle disorder in humans. It is an inherited disorder which causes toxic levels of ammonia to build up in the blood. That's what we were talking about before. So what we find here is that ornithine becomes like a blotting paper to ammonia. So when you get a buildup of ammonia, usually because the arginase enzyme, as we'll see, doesn't function properly, the ornithine will carry it and recycle it and help the body to dispose of it. If you get a buildup of ammonia, if you remember, it's neurotoxic, it's nephrotoxic, and it's cardiac toxic. It can set off irritation of the AV and SA nodes there. Here's that picture again of the urea cycle. Let's just review again. Ammonia coming in here from the breakdown of proteins. So the higher the person's protein diet, the more transamination or breaking down will occur and the greater the ammonia. But the body does produce ammonia in other pathways, and microbes in the gut produce ammonia which gets readily absorbed from the intestines here. So ammonia then blends with carbon dioxide and water to make carbamyl phosphate, which then goes on to make that amino acid citrulline that we just said is rich in watermelon seeds, or watermelons and the seed, yeah. This then goes round to make arginosuccinate to arginine, which we talked about as the amino acid. So here we can see that we can make arginine ourselves, so that's why it's not an essential amino acid to humans, but is in a lot of other animals. Now, arginine is then converted into ornithine with an enzyme called arginase, which then gives off urea, or 2 molecules of ammonia in the process, which is formed what we call urea, which we wee out. Okay? So arginine here goes on to make ornithine. So if there's a genetic defect in arginase enzyme, we may get a build-up of ammonia. It doesn't get cycled out of the body. And that arginase doesn't have any cofactors that are, coenzymes that are known, but it's cofactored by manganese. Personally, I haven't found anybody ever respond to manganese who has this problem, but they have a defect in the enzyme, and so they have to take ornithine. And once they start taking ornithine, usually those neurological effects of the bad dreams and the emotions, the doom and gloom, soon lift, which is a godsend for them. It's really fantastic. But it doesn't necessarily cure the problem, but it does act like a blotting paper. And if this enzyme defect is, perhaps only expressing itself at 30%, they may have to continue to take the ornithine. As I said, it is one of the most common defects in the urea cycle here. What we've also found, and we don't know why this is that people get a build-up of ammonia when they jet travel, particularly if you go long distance. Now, you don't get this if you go shorter distances like Europe, and I think one of the reasons is you don't go so high. Okay, when you do long haul, you go high, so you're getting towards 40,000 feet. When you do European, you're sort of 28, 30,000 feet. And the higher you go, you get more exposure to solar radiation. Okay, so the solar radiation is greater, in other words, cosmic radiation is greater, which will pass straight through the airplane, and you in the process of it. So this is why long haul will have an effect on your body clock and all sorts of systems in the body. And what we found is that ornithine is very good at relieving the symptoms of jet lag and protecting you from cosmic radiation. But we don't really understand why that is. But a lot of crew get it. We should stand at the doorway here and offer ornithine packages as a discount for pilots and aircrew, because they're up in that lot all the time. Now, we found this out because We do a lot of jet travel, and trips like to Los Angeles, the flight tends to leave here at 3 o'clock in the afternoon, and we arrive there at 6 or 7 o'clock in the evening. So we've gone for 12 hours in distance in the sunshine. So it's in the afternoon all the time when we land in the afternoon, and then you have something to eat, and then you go to bed, and bang, you wake up at 2 o'clock in the morning, and you feel awful, and you feel really, this is crazy, you slept some of the journey, and yet you just, feel absolutely washed out and whacked out. And ornithine tends to help this tremendously. When you go if you go the other way, you go to Australia, again, you're going east, you tend to go through one day, and then you go through a lot of sunshine, you see, and then you land in Australia, and like this. And all you want to do is go to bed until you let your body's clock reset itself. When you come back, you get on the airplane in the evening, early evening Australia, and you arrive at 5 o'clock in the morning of the same day. So you gain your 12 hours back, get off the plane, and then you can go to work. It's amazing. You think, oh, what's wrong? It's because you come back at night time. And it's a simple sort of process. The more you travel at night time, the better it is with jet travel. So whenever you can, if you're going intercontinental, go at night time because you're not exposed to the cosmic radiation. And don't sit underneath the pilot's cockpit. Okay? If you're privileged enough to be in first class is underneath the pilot's cockpit in the jumbos and bigger planes, and that's where all the electronics are. So be very careful about being too far forward on the airplane. It's better to sit above the wings. That's the safest place in an airplane, is above the wings. So travel at night time, and always take ornithine. A couple of capsules is usually enough before you travel, okay? And that helps to protect you against the effects of cosmic radiation. We'll find out clearly the cosmic radiation is not creating ammonia. What we think it probably does is it inhibits one of these enzymes in some way from functioning. So you don't break down arginine, so you get a build-up of ammonia, and that's what makes you get the jet lag, is really a build-up of ammonia. So I think ornithine there. And the other, while we're on the subject of that, do always take omega-3 oils before you travel as well, particularly longer flights. If it's a longer flight, take at least 3 before you go and a 3 halfway. So if you're stopping off somewhere, make sure you've got some omega-3 in your wallet or your handbag, because keep that blood thin down, keep the platelet levels from clumping together, because that's one of the dangers of long-haul flight, of deep vein thrombosis. And omega-3 oils do help to stop the blood from agglutinating together. So 3 omega-3s well before you fly. It's also one of the best sun protections if you're going somewhere hot, because the exposure to ultraviolet does oxidize those oils in your skin. And so replacing those with omega-3 and using sun lotion is a good idea to protect the sun from the extremes of the ultraviolet B. So urea cycle. Okay. Some years ago, I added to this, and you'll see in this particular one of mine, my own observation was that different bacteria, which we'll talk about in the microbiome seminar, seem to contain the protein structure, or the DNA, for different enzymes in the body. And so what I was able to do with here, by using the individual intermediates, is to say that this conversion of arginosuccinate to arginine will be helped by B. bifidum, which is a bacteria in the large intestine. Arginase would be helped by Lactobacillus bulgaricus. And then the ornithine across round to citrulline here by L. lactis, which is a bacteria they make French cheeses like Camembert from. So it's interesting that bacteria have a lot of DNA material, but no one individual has all of them. But all the bacteria together, as we'll see when we do the microbiome seminar, is if you put all the essential bacteria together, they've got something like 10 or more times the bacterial genetic sequences that the human being's got. So inside the bacteria are all the answers to our problems. So probiotics are an essential part of looking at people as well from an individual perspective, rather than just putting on a bulk probiotic may not show, rather like the amino acids. So we come back to that and test those, because it's worthwhile saying, well, yeah, a person has got an arginase deficiency, But can we do anything to help build that up? Can we do anything? And maybe probiotics might be help the answer to a lot of genetic defects in the time to come. Okay, citrulline, this is the, if we go back to that one, we'll see that ornithine goes round then, it receives the ammonia from this pathway and forms citrulline. So citrulline will go on round to make arginine again. So in a lot of products contain citrulline as a stimulant in the nitric oxide pathway here, rather than arginine, because arginine can cause a vasodilation too much. So if you take arginine, you may go bright red, a bit like a niacin flash. But if you take citrulline, it tends to do it in a more gentle way. So citrulline is not an amino acid that builds proteins again. It's an intermediate, but occasionally it does show up as a detoxifier, rather like ornithine. So it's a key intermediate in the urocycle, in the way that mammals excrete ammonia by converting it to urea. It is also produced as a byproduct of the enzymic production of nitric oxide from arginine. Now, probably the last one I think of the non-proteolytic proteome-building amino acids is S-adenosylmethionine. We briefly saw that with the one carbon cycle from methionine round to homocysteine. So this is often shortened to SAM or SAMe, SAMe, as a product. It's a common co-substrate involved in the methyl transferase and transsalvation pathway. Most SAMe is produced and consumed in the liver. More than 40 methyl transfers of SAM are known to various substrates. We looked at a few of those methylation pathways where the body uses methylation. We're going to talk longer about that this afternoon. So SAM is an important intermediate substance. Again, should you administer it to a patient? The answer is yes, if the enzyme that converts methionine through isn't functioning properly. So if it's a polymorphism in that enzyme and it's only expressing itself to 30%, 50%, you may need to take S-adenosylmethionine as a supplement. Is to pull the knee to your shoulder, and what you're going to do is we're going to find the weak muscle, which is the heart meridian, is the subscapularis. Luckily there's only one muscle associated with that. So push the hand to the floor. Glenda's coughing a little bit, so it could be a bacteria or a virus, so we're going to see if threonine in this case improves her immune system, using the right subscapularis as our weak associated muscle. So if you just put a little bit of threonine on the tongue, okay, and then push the hand to the floor, and it strengthens up very nicely. So threonine is associated with the heart muscle here, and as the heart muscle was associated with the primary muscle with you at the moment in relationship to the infection, we might try threonine as a supplement to boost your immune system. Yeah, okay, ready? So pull your knee to your shoulder, if you will, that's it. And what I'm going to get you to do is just tug the skin on the back of your hand there. Keep it tugged, don't let go. So when we stretch the collagen, it stay there, okay? And now put a little bit of, in this case, lysine is the amino acid that we've chosen. And pull, and it negates the weakness. So lysine is a good amino acid to help synthesize collagen. Okay, that's you done, thank you. So what we've got here, if you hold on just, that's right, and push both legs towards Gary, is we've got a weak left quadratus lumborum muscle here. We're going to just demonstrate that we've got a gallbladder, so we touch over the gallbladder area here with a strong indicator muscle. So we're looking here for the relationship to bile over the heart, and gentle pressure first of all on an eyeball, just touch, and then press a little bit harder. So a little bit of gentle pressure there brings that, and again on that one. Okay, gentle pressure, good. And then just therapy localized, say with that one, onto the large intestine endpoint or big endpoint on that one. Good. So we've got all our markers there. So we put a little bit of taurine on the tongue. Keep that on your tongue, and we'll go through one by one. The most important, of course, is again is the muscle test. Does it strengthen? Push both legs towards Gary, which they do. Okay, and then we'll just check quickly here while she's got it on the tongue still. Gallbladder, heart, pressure on the eye, just a little bit gentle pressure, and the same on the other side. And therapy localize the end point there. Perfect. Okay. Good. Excellent.